Lesson 3.3, Rotations. This lesson starts out with a question about a clock and the arms on the clock. So it says, Felipe says that the next time one of the hands of the clock points to 7, it will be 7. When the hour hand points to 7, Nadia says it will be 5:35 when the minute hand points to 7. So think about when telling time, who's correct, and explain why. Now it says, suppose the numbers on the clock face are removed. What instructions that another person could follow to move the minute hand from 2 to 6? If there were no numbers here written on the clock, how would you give directions to go from 2 to directly down where 6 should be if there were no numbers? So you have to think about that for a second and try to figure that out. Example 1, draw a rotated image. So rotations, it's kind of great because rotations use actual measurements. So it's an exact measurement in degrees. So it says, how can you perform a 75-degree rotation of this triangle about point B? About means from point P, so or around point P. So I want you to think of point P as like the center of the clock, and this triangle is like going around it. That's a rotation. So first of all, you have to be able to figure out how to move 75 degrees. So if we were live and using actual compass and protractor, I would have you get out your protractor and figure out how to measure 75 degrees. Online, you can actually do actual math computer software that we're going to use here in a second that can help you do that. And you'll do it on some of your problems. So I want you to look at this. It says, okay, figure out the triangle, figure out what the point of rotation is, which it is here, and then we're going to go through each step. Bottom line is you have to move point Y 75 degrees around P, point X 75 degrees, and point Z 75 degrees around point P. So first, you draw a segment. Draw a segment from P to one of the points on the visual or on the figure. And then from here, you're going to make this angle open up to 75 degrees. Let's see. Here it is. So 75 P to X is the exact same distance as P to X prime. So in live or hands-on constructions, you would take a compass from point P and X, rotate your circle, and basically that radius would stay the same. So P to X and P to X prime, you would use the compass to help you find this point and the protractor to help you find the degree. Okay, but the thing is, that's just one point. You have to do it to all the points in the figure. So they start with another point. They just said, do the same thing to Y and Z prime. So from point P, follow along because it gets really ugly. P to Y, they drew a segment. Then they measured 75 degrees and drew the exact same segment. There's Y prime. And it's really helpful if you're doing this to label the points. From P to Z, make the segment, rotate it 75 degrees, make the segment exactly the same or congruent to P to Z. And there's Z prime. Step 4 is actually just put the pieces together by connecting them with segments. Now, for whatever reason, if the pre-image and the image do not look alike, most likely the degrees of one or more of these rotations was incorrect. Because if all the degrees are correct and all the segments are congruent to the corresponding segments, this should look identical, just rotated however many degrees the problem was moving. Do you think a rotated image would ever coincide or match up, like overlap, with the original figure so that you would not even see the original? It'd just be like one figure. If so, how many degrees would that be? How much would you have to rotate it so that this triangle and the image of the new triangle would end up at the exact same spot? Rotations. Here's the description, and this is how they write it. Rotations is a lowercase r, and it has the degree in which you're rotating and the point. So this is point P. That is the point of rotation. Degrees, x degrees, that's just how much you're actually rotating. In the last problem, it was 75. So the image of P is P prime, meaning point P doesn't actually rotate at all because that's the point of rotation. Everything else moves around it, but P does not move. A to P, A prime to B, P, those have to be congruent. Those are the little notches that say these are congruent. And then this degree X will happen on every single point. So point C will rotate X degrees. Point B will rotate that exact same X degrees. And then point A is already rotated X degrees. So here's the notation. And you'll have the pre-image and the image. Now we're going to do it on a coordinate plane. These rules are things you are going to want to write down. You want to have this in your notebook or your notes somewhere. This is kind of come in handy. It actually saves you a lot of stress, but if you ever forget it, it's okay because then you would just have to figure it out as you draw and manipulate patterns on a graph. So I'm just going to put this wherever. It doesn't matter. Okay, 1.21. And this rule says if I am rotating 90 degrees around the origin, point O, then what will happen? My xy will turn into negative yx, which means whatever my x value is, which if on this problem it's a 2, it's going to end up in the y spot. And whatever the y value is, 1.21, that's going to end up in the x spot, and it's going to be negative. So at first you might be like, what are you talking about? But I'm going to show you how this works. And this is really helpful to manipulate. So I'm going to say 90 degrees. It's going to rotate 90. Hey, look, 90 degrees. That actually looks like a 90-degree angle. The 2 is now in the y spot. The 1.21 is now in the x spot, and it's negative. So this is what that rule means. If you haven't written it down, write it down now, because otherwise any problem that you have, you're going to have to figure out this rotation, and you're going to have to count or calculate how to rotate that. Okay, rotating 180 degrees around the origin again. Now this only works around the origin. If it's from a different point, it's going to be a little different. So the concepts are there, but just it won't be this exact same change in the coordinates. So around 180. The x becomes negative x. The y becomes negative y. Because this, it goes over 2, up 1.2. Now it's going to go over 2 that way, down 1.2. So let me show you. There it is. And see, it's exactly 180 degrees around the origin. So instead of going right 2, it's going left. Instead of going up, it's going down 1.21. Okay, so exactly the same order, just negative. Negate what you have. And then 270 degrees, that's one more rotation of 90 degrees. You're going to have the x and y are going to switch locations, kind of like they did over here, but the x becomes negative. So whenever you're dealing with 90 or 270, the order switches, but the negation changes. So just be careful. 270. There's my little Pac-Man. So instead of going to 1.2, it goes 1.2 down 2. Okay, again, write these down. You definitely want those in your notes, and they'll be very helpful, even on the next problem. It starts with the problem. It says, what is the rotation 90 degrees of point O? If I didn't have those rules that I just told you to write down, then I would actually have to figure this out. Okay, from point O, it goes over 2 and down 1. So that's over 2, down 1. I would need to rotate that 90. It would go up amount. And you would have to do that for every point. Okay, how much would it go up instead of over? Or you look at the notes that you just wrote down and you say, okay, if it rotates 90, then the x's and y's switch location, and the new y or the x spot where it's y, it's going to be negative. So let me show you how this works. So remember the negative y in the new x spot. So instead of 5, it's going to be in the x, negative 5. 7 goes to the x spot, negative. 4 goes to the x spot, negative 4. Negative 1 goes in the x spot, and negate a negative is a positive. So let me show you how to, and then the x's just go to the y spot. Let me show you what it looks like. Here it is. So if you don't have that rule memorized, or you understand it, or have it written down somewhere that you can look at, you're going to have to go through and figure out every single point on your own. Okay, here's the vertices. These are the vertices. What are the vertices if I rotated there's no graph here. It's a little bit harder to figure out and actually count and manipulate. So you're going to have to know those rules. If you have the rules for 180 degrees around the origin, then you should know x and y stay the same, but they're negative x and negative y. So hopefully that helps. And then 270, I'm not going to tell you. You're going to have to go look and figure out what are those rules. All right, this is an application. This problem overall seems ridiculously complicated until you visualize it. Once you visualize it, I'm hoping you can understand it. And the nice thing is the book actually does it for you. So it says the first drummer in a drum line is at the 20-yard line. So I'm going to just show you the visual. Visualize, drummer in a drum line, 20-yard line, and the sixth drummer is at the 35-yard line. So 20, 35. So there's like a spread of people between the first and the sixth right there. The drum line rotates counterclockwise. Counterclockwise is the opposite direction of what a clock does. So it's going to rotate counterclockwise. So clocks go this way, so that means I have to go this way, 180 degrees. About the sixth drummer. So that means the sixth drummer is the point of rotation. So first drummer, sixth drummer, they're going to rotate around and just make sure to go counterclockwise. And they're going to rotate 135 degrees or after that. So 180 and then rotates 135 clockwise. So you're going counterclockwise 180, then you're going clockwise 135 around the first drummer. Where does the sixth drummer stand? So we're going to walk through this each time. First, draw what you have. This is where you're starting. Point B is the first drummer, and the sixth drummer is point A. And it explains that there. So from this point, I'm going to rotate counterclockwise 180 degrees. Now, it's 180. So clockwise or counterclockwise, it's still going to end up here. But this is clockwise because this is the way the hands go on a clock. But this is counterclockwise. So we're going to go there, 180, and it should end up over there. There it is, 180. Notice the direction it went. And then we're going to rotate 135 from B prime. And it says clockwise. So from here, I'm going to rotate these drummers this way, 135 degrees. There they are, right there. Okay, and then it says describe, or how does the sixth drummer stand after the rotation? Describe the change in position. So do you remember where the sixth drummer is? And where did the sixth drummer end up? And so the conclusion, it says the sixth drummer stands at the position A double prime. The drummer is the first translation by rotation and then rotation this much. So basically they just explained first they rotated, then they rotated again. So visualize it. Anytime there's a visual, and it's especially multi-step, you draw the visual so that you can understand and comprehend what's going on. There's another one. This is in try it. Suppose the drum line instead turns counterclockwise around point B prime. How many degrees must it rotate so the sixth drummer ends up in the same position? So sixth drummer, instead of going 135 this way, how much would you have to go this way counterclockwise to end up at A prime? So good luck.